The idea of dynamic equilibrium. So a reversible reaction is one that can proceed in both directions. It can go forward and reverse. And we write them an equation like this with a double-headed arrow showing that it can go in the forward direction and in the reverse direction. Those reactions are occurring at the same time but in opposite directions. So we have the concentrations of the reactants and the products at equilibrium are not actually changing. Even though some of the reactants are producing products, some of the products are also reacting to reform the reactants. It's occurring at the same time. So let's look at how this comes about. If we look at this reaction between hydrogen and iodine, it's a reversible reaction. Here at 0 time, we have 8 molecules of hydrogen, 8 molecules of iodine, and no hydrogen iodide, no product. So the reverse reaction cannot occur, only the forward reaction, because there aren't any products to react backwards to form reactants again. So at 15 seconds, now some of the hydrogen and the iodine have reacted. We've got 6 hydrogen molecules left and 6 iodine molecules left, and we formed 4 hydrogen iodide molecules. At 30 seconds, the reaction, forward reaction, has proceeded further, and now we have 4 hydrogen molecules and 4 iodine molecules and 8 hydrogen iodide molecules. So these 8 hydrogen iodide molecules can react with each other to reproduce hydrogen and iodine at the same time that hydrogen and iodine are combining to form HI. At 45 seconds, we see that the numbers of molecules hasn't changed. We have reached equilibrium. You could wait all day long, and the concentrations are going to stay the same. That does not mean that you have an equal amount of reactants and products. Notice that we have twice as many hydrogen iodide molecules as we do of our starting molecules. It's just that the forward and reverse reaction are occurring at the same rate. So an analogy for this involves population. So I love this one. So here we have a map, and we've got Narnia on this side and Middle-earth on this side, and there's a river that forms the boundary between them. So initially, let's say that there's a lot of people living in Narnia. The population is high. It's fairly dense. There's very few people living in Middle-earth. People here are competing for resources and land, and they look across the river and say, hey, I could go over there and have plenty of space. And so we have a lot of people migrating, emigrating, moving to Middle-earth from Narnia. There's hardly anybody over here, so the rate of people moving from Middle-earth back to Narnia is very low, if it is occurring at all. After this migration occurs for a while, now we have more equal numbers of people on the Narnia side and the Middle-earth side. The population density is approximately the same. So we have people still moving from Narnia to Middle-earth, but we also have people moving from Middle-earth back to Narnia, because the grass is always greener on the other side of the river, right? It's like, well, things aren't so great here. I think I'm going to try over there. The difference between this situation and the initial situation is, in the initial situation, there was hardly anybody over here to want to move. Now we've got people on both sides, and so some of these people are going to want to move back to Narnia, and other people are going to continue to move from Narnia to Middle-earth. Any questions about that? Does that make sense? If you think about, say, the population of Fresno, most of the time it's relatively constant. We don't have huge population surges, right? We have people moving in and people moving out. How's another way that the population can increase? Births. And it could decrease through deaths, right? So if you have, let's say you have a closed community, nobody can move out or in, the population is still in a state of flux because you have people being born and people dying. And it's going both ways, right? If the rate of births is the same as the rate of deaths, then the population stays constant and nothing changes. Is it always the same people in that population? No, because you have new people being born and old people dying, right? So it's changing over. There's action going on, and yet overall the population is stable. So dynamic equilibrium, when we have the rates of people moving from Middle Earth to Narnia equal to the rate of people moving from Narnia to Middle Earth. Fine. So be sure to watch that video. Does anybody have any questions about the video? Does that help? Did that help with making sense of what equilibrium is? You guys gonna wake up later? I had 2 rock stars. I'm like, maybe I should have brought them for you guys.